Hello students, welcome to the lecture on description of pointer and structure. And after the lecture we will be able to learn the following objectives. Explain pointers and its declaration. Define the operations on pointers. Understand arrays of pointers. Explain the structures and how it definition. Discuss array of structure. Let's start with a brief introduction to pointer and structure. A pointer is a variable that contains the address of a variable. Pointers provide a mechanism for the direct manipulation of memory. They are arguably the most powerful and the most dangerous feature in C programming language. To the novice programmer who has not before encountered address-based computation, pointers can be a difficult concept to grasp. But with a little experience, they can be used to produce concise and efficient code. Pointers have been lumped with the go-to statement as a marvelous way to create impossible to understand programs. This is certainly true when they are used carelessly, and it is easy to create pointers that point somewhere unexpected. With discipline, however, pointers can also be used to achieve clarity and simplicity. Let's discuss the concept of pointers. To explain the operation of a pointer, it is first necessary to understand, at least in a basic sense, the way in which memory is organized. A typical machine has an array of consecutively numbered memory cells. These numbers are termed addresses. Each cell consists of a set of bits, and the cell bit pattern is the cell's value. When a variable is defined, it is allocated a portion of memory. Thus, the variable has a value and an address for where the value resides.
It's pretty straightforward. It just uses that pair of variables that we were looking at in the slides. But now I want to actually go and look at some of the syntax. Here we have 4 lines of code. The question is, which one of these four, is a legal and meaningful first step that this program could carry out? What do I mean by legal and meaningful? Well, firstly, that it will compile. And secondly, that it will actually do something that won't crash the program, or is actually useful, or valid, or whatever you want to call it. I'll give you a hint. 2 of them are legal. In other words, they will compile, and 2 of them will not compile. Of the 2 that will compile, only 1 of them is legal and meaningful. Now, I'm going to go through this slowly by explaining what each one of these lines does. I'm going to put a little comment next to it. Those comments will be saved in this file pointer.c, so when you go and look at it, it will have comments in it. And I'll explain each one as we go. Okay, let's have a look at the first one. What's going on here? This says star PTR equals x. So let's try and translate that into English. The contents, or the thing that PTR points to, the value that the thing that PTR points to is set to x. Is that legal? Well, x is an integer. Good, so it is legal. That will compile. So I'll now put a comment next to that. So it's legal, but is it meaningful? Is it useful to do that as a first step in this program? And the answer is no. It isn't. Why not? Well, because I actually did discuss this in the slides. PTR has not yet been initialized. The pointer variable itself is just pointing off to some random area of memory. You have no idea where it's pointing to at the moment. So what you're doing here is you're effectively taking the value of x, whatever that happens to be, and that's not initialized either, but that's not quite so crucial. You're taking whatever integer value is in x, and you're assigning it into some random area of memory. In other words, you're overwriting some piece of memory that you have no idea which piece of memory it is, and you're overwriting it with some random number. So that is not a good first step for this program. I'll just put that into the comment as well. So it's legal, but it's unwise because PTR is not initialized. Neither is x, but that's not quite so crucial. Let's look at the next line of code. Address of PTR equals x. Now, will that compile? What does that mean? It means take the address of the pointer. Take the address of the pointer? You can take addresses of pointers. They are variables, and every variable has an address. If you recall back to our slide, x had the address of 103, and PTR obviously had the address of, I think it was 111. So pointers have addresses as well. So it's actually possible to have a pointer to a pointer, but we'll look at that in a later chapter. I know that sounds scary, but it is perfectly okay. Anyway, the address of pointer, let's think back to our example, that would have been 111, and we're trying to set that to x. Now, the address of the pointer is the address of the pointer. We can't change it. We can't move pointer from one place to another, which is what it looks like we're trying to do here. If PTR is 111, so if the address of PTR is 111, that's cast in stone. PTR lives there, and that's where it lives. We cannot ask it to live somewhere else. So that is not legal. The compiler will reject that. So I'll put that in there. Okay, so we're actually, it seems like we're attempting to move PTR around from one place to another, and you simply can't do that. It's not a valid thing to do in C. Okay, let's look at the third example. PTR equals address of x. So it means take the address of x and assign that to the variable called pointer. Now the address of x is, well, from the example before it was, what, 103, and PTR is a variable that can contain an address, so it looks pretty legal. It is legal. I'll put that in now. The next question is it meaningful? Is it okay to do this as a first step in a program? And yes, it is. It's an initialization. It's setting pointer to be equal to something. It's initializing pointer. It's saying, okay, I've got a pointer here that doesn't point to anything at the moment, set it to point to x. It doesn't matter that x is not initialized yet. We can initialize x next, or we could have already initialized x. It doesn't really matter. All we're doing here is initializing pointer. We're setting that big yellow arrow to point to 103, the memory address 103. So I'll just write that into the comment as well. Okay, so it's legal and meaningful. We're initializing pointer. So obviously the final one is not legal and it's not meaningful. Why not? Well, we're almost like we're pretending that x is a pointer, and we're trying to find the thing that x points to. But x is not a pointer. X is just a plain old integer, so x cannot possibly point to something. So taking the contents of x is a meaningless thing to do. So I'll just write that into the comment as well. Okay, so x is not a pointer, it can't point to anything. Okay, that's all I wanted to show you in this particular example. I've got another file prepared called pointer2.c. Let's have a look at that. Here we are, pointer2.c. This one, we actually are we're trying to achieve something. We've got a float called f, and we've got a pointer to a float called ptr. What's our task? Our task is to get the value of 3.5 into f. That's our task. Oh, that sounds easy enough. Let's do that. F equals 3.5. Simple. Okay, we also want to do it without using a statement that begins f equals. Notice this statement does, of course, begin f equals. Okay, so we obviously can't do that. What can we do? Let's get rid of all these question marks. Well, we can, if you like, assign a pointer to point to f, and then, by using the pointer itself, we can say the thing that the pointer points to, set that to 3.5. Now that will effectively set f to 3.5, but we'll be doing it via the pointer. So that's a two-step process. First of all, we need to set pointer to point to f. You remember how that's done? Okay, so we need to set pointer to equal what? Well, we need it to point to f, so it needs to be set to be the address of f. Okay, so that's a simple pointer initialization. Next, we need to say that the thing that pointer points to, set that to 3.5. So, the thing that pointer points to is written asterisk ptr, we set that to 3.5. Okay, now, will it compile and will it work? Those are the questions. Let's try and find out. Compile. So it does compile. Does it run? The value of f is 3.50000. So that's working.
Declarations of pointer. A pointer declaration names a pointer variable and specifies the type of the object to which the variable points. A variable declared as a pointer holds a memory address. Passing pointers to a function. As one has seen in C, arguments are passed to functions by value, that is, only the values of argument expressions are passed to the called function. Some programming languages allow arguments passed by reference, which allows the called function to make changes in argument objects. C allows only call by value, not call by reference. However, if a called function is to change the value of an object defined in the calling function, it can be passed a value, which is a pointer to the object. Let's now talk about operations on pointers. C offers several basic operations one can perform on pointers. The basic operations that can be performed with or on pointer variables. Assignment. One can assign an address to a pointer. Typically, one does this by using an array name or by using the address operator. Value finding, dereferencing. The multiply operator gives the value stored in the pointed to location. Taking a pointer address. Like all variables, pointer variables have an address and a value. The address operator tells one where the pointer itself is stored. Adding an integer to a pointer. One can use the addition operator to add an integer to a pointer, or a pointer to an integer. In either case, the integer is multiplied by the number of bytes in the pointed to type, and the result is added to the original address. This makes pointer 1 plus 4 the same as AND symbol URN brackets 4. The result of addition is undefined if it lies outside the array into which the original pointer points, except that the address 1 past the end element of the array is guaranteed to be valid. Incrementing a pointer. Incrementing a pointer to an array element makes it move to the next element of the array. Therefore, pointer plus plus increases the numerical value of pointer by 4. Subtracting an integer from a pointer. One can use the operator to subtract an integer from a pointer. The pointer has to be the first operand, or a pointer to an integer. The integer is multiplied by the number of bytes in the pointed to type, and the result is subtracted from the original address. This makes pointer 3 minus 2 the same as AND symbol URN brackets 2, because PTR3 points to AND symbol URN brackets 4. The result of subtraction is undefined if it lies outside of the array into which the original pointer points, except that the address 1 past the end element of the array is guaranteed to be valid. Decrementing a pointer. One can also decrement a pointer. Decrementing PTR2 makes it point to the second array element instead of the third. One can use both the prefix and postfix forms of the increment and decrement operators. Both PTR1 and PTR2 wind up pointing to the same element, URN brackets 1, before they get reset. Differencing. One can find the difference between two pointers. Normally, one does this for two pointers to elements that are in the same array to find out how far apart the elements are. The result is the same units as the type size. Comparisons. One can use the relational operators to compare the values of two pointers, provided the pointers are of the same type. We shall now discuss about pointer arithmetic. Each variable type has a corresponding pointer type. This allows the compiler to automatically calculate the byte offset required for indexing an array of that type. For example, on many machines, a double is 8 minus bytes long. Suppose a double pointer PD has some initial value and is then incremented by 1 PD++. The address now held by PD is 8 bytes beyond the original address, so that it points to the next double. This mechanism makes pointer arithmetic simple and uniform for all types, and hides the details of type sizes from the programmer. Pointers and arrays. An array is a group of variables of a particular type occupying a contiguous region of memory. In C, array elements are numbered from 0, so that an array of size n is indexed from 0 to n minus 1. An array must contain at least one element, and it is an error to define an empty array. Relation between arrays and pointers. In arrays of C programming, name of the array always points to the first element of an array. Here, address of first element of an array is AND symbol array bracket 0. Also, array represents the address of the pointer where it is pointing. Hence, AND symbol array bracket 0 is equivalent to array. Also, value inside the address AND symbol array bracket 0 and address array are equal. Value in address AND symbol array bracket 0 is array bracket 0, and value in address array is pointer array. Hence, array bracket 0 is equivalent to pointer array. Now let's talk about the array of pointers. An array of pointers is a standard array data type that holds a sequence of memory addressed to data types as opposed to holding other scalar types such as integers or floating point numbers. By using an array of pointers, a program is able to have an array of nearly any data type, data structure, class, or even function. Efficient sorting of an array of pointers also is possible so that, if desired, the addresses can be aligned according to their physical location in computer memory. Some of the complications in using an array of pointers are that the data can be easily corrupted, and that the type of data being pointed to needs to be managed internally to prevent memory overflow problems. Now let's explore the function pointers. In C, a function itself is not a variable, but it is possible to define pointers to functions, which can be assigned, placed in arrays, passed to functions, returned by functions, and so on. Function pointers are a very useful mechanism for selecting, substituting, or grouping together functions of a particular form. For example, they may be used to pass functions as arguments to other functions. Or they may be collected into an array of function pointers as a dispatch table, where a certain function is invoked based on an array index. Now let's explore the structures in C. A structure is a collection of one or more variables, possibly of different types, grouped together under a single name for convenient handling. Structures help to organize complicated data, particularly in large programs, because they permit a group of related variables to be treated as a unit instead of as separate entities. The C language provides means to create user-defined types called structures. These types are aggregates of basic types and other user-defined types and permit a logical grouping of related data. Defining of structures. A structure is declared using the keyword struct, and the internal organization of the structure is defined by a set of variables enclosed in braces. By convention, structures should always be named with an uppercase first letter. Processing of structures. The operations permitted on structures are a subset of the operations permitted on basic types, such as integer, double, etc. Structures may be copied or assigned, but it is not possible to directly compare two structures. Passing to a function. C programming language allows one to pass a pointer to a function. To do so, simply declare the function parameter as a pointer type. Unions. A union is a variable that may hold, at different times, objects of different types and sizes, with the compiler keeping track of size and alignment requirements. Unions provide a way to manipulate different kinds of data in a single area of storage, without embedding any machine-dependent information in the program. Accessing members of a union type is also the same as for structures, with the member operator for union objects and the operator for pointers to union objects. Type DEF. In effect, type DEF is like hash define, except that since it is interpreted by the compiler, it can cope with textual substitutions beyond the capabilities of the preprocessor. The keyword type DEF provides a means for creating new data type names. It does not create a new type, but merely adds a new name for some existing type. Now let's understand the array of structure. As for basic types, it is possible to create an array of structures. The elements of the array may be initialized by a brace-enclosed initializer list, and when doing so, the size of the array need not be specified. An example is shown here. Pointer to structure. The pointers to structures vary in similar way as one defines pointer to any other variable as shown. Now one can store the address of a structure variable in the defined pointer variable. To find the address of a structure variable, place the address operator before the structure's name as shown. Now in the end, let us summarize what we have learned in this lecture. A pointer is a variable that contains the address of a variable. Pointers provide a mechanism for the direct manipulation of memory. The size of a pointer type determines the maximum value it can represent, and hence the maximum range of addresses it can deal with. Some programming languages allow arguments passed by reference, which allows the called function to make changes in argument objects. An array is a group of variables of a particular type occupying a contiguous region of memory. In C, array elements are numbered from 0, so that an array of size n is indexed from 0 to n minus 1. In arrays of C programming, name of the array always points to the first element of an array.